All right, so to illustrate how you would use these inverse functions to solve your problem, we're going to solve a reasonably challenging one here, in which we have 5 times the sine of 2x plus 5 is equal to 2. Now, in order to do this, we're going to do the exact same procedure that we did before, moving from the bottom of order operations up to the top. Now, functions are at the top, so what you're going to do is you're going to get rid of everything else first. So if you take a look at this, the very first thing that you're going to want to remove is this multiplication by 5 that is on the left-hand side. As before, nothing here has changed. If you want to remove a multiplication by 5, you can simply utilize a division by 5. Again, make sure you apply this thing to both sides entirely. On the left-hand side, it will eliminate the multiplication by 5. And on the right-hand side, you can simply evaluate 2 divided by 5. Right, and that will eliminate everything except the function itself. Now, you're left with the function itself. You can't access anything that's inside the function until you eliminate it. So what you need to do here is you need to eliminate this function by applying the inverse function to both sides. So on the left-hand side here, what you're going to want to do is you're going to apply the inverse sine function to it. And this inverse sine function is going to contain everything on that side. So we're going to put some pair of braces around it to indicate that it contains it. And on the right-hand side here, again, you're going to apply the inverse sine function. So a sine here. One second, let me just space this out well, so that it contains everything that was originally on the left-hand side. Like so. Now, when you're dealing with this, on the left-hand side here, these are going to cancel out with one another. So basically on the left-hand side here, you'll simply leave up with 2x plus 5, which is something that you know that can be isolated again with just inverse operations. Now, on the right-hand side, you're going to apply the inverse sine function of 0.4. Now, we're going to get to this more later, but when you're dealing with these functions, often the mode that your calculator sets is going to affect what you get. By default, in order to solve this or any of these functions, we are often going to be working in radians. So if you're using a calculator, you can press the mode button and switch it to radians. However, the takeaway is if you apply the inverse sine function to 0.4, whether you're in degrees or radians, you're going to get a number. So I'm going to work in radians here. When I apply the inverse sine function to 0.4, it literally gives me a number. Right? So anytime you're applying a function to a number, you're going to get a number. If you're more comfortable just working with the decimals, the minute you've done this, simply put it into a number. Now, with that being said, we would continue on with this doing our normal algebraic procedure. So taking a look at this new equation that we're left with, we want to get rid of the 2 and the 5 here. We're going to start with the simplest operation here, which is the addition by 5. So we're going to subtract 5 from both sides. This is going to leave us on the left-hand side with simply 2 times x. And on the right-hand side, we are going to have 0.411 minus 5. This is going to give us negative 4.588. Now, lastly, we can eliminate this multiplication by 2 with a division by 2, applying it again to both sides. Now, this will leave us with just x on the left-hand side, and on the right-hand side, we will be left with simply negative 2.29, or thereabouts. So dealing with these functions is not actually significantly different from removing things like addition and multiplication. The only difference is you do need to know what the inverse function is in order to eliminate it.